Hello, good morning, guys. So today we're going to be looking at linked list data structure. So before I start, want to brief you guys on what linked list is. So linked list is a linear data structure which stores elements in a node, where each node contains a data and a pointer with a reference to the next node in the sequence. So like what are nodes? Nodes are used to store information in linked list. So now let's get started. So in order to create our linked list, we first of all have to create an empty node. So we're going to use class to do that. So inside our empty node, we're going to have our value, which is our data, mapped to number. Because we're going to be working with number today. And we're going to have the next, which is the pointer in our linked list. And its value is going to be mapped to a node or node. This is because the pointer is either pointing to the head of the next node or is pointing to node. In the case where a the pointer of a node is pointing to node, that node is known as the tail of that linked list. But if you have a node in a linked list where it's okay, let me demonstrate that. So for example, in our linked list, we have 4 nodes. So our linked list is going to have the data, which is the head of that node, and the pointer, which is the tail. So the pointer is pointing to the head of the next node in the sequence, whereas the next node is doing the same thing. So the last node, the last node in the sequence, which doesn't have a head to point to, is going to be pointing to null. So this node is known as the tail node. While this node, which doesn't have a pointer pointing to its head, is known as the head node of that sequence. So without further ado, let's continue. So in our class, what all class have to have is a constructor. And in our constructor, we're going to have our value.
This dot next.
So in our constructor, I will use our this keyword to call our value and say this dot value is equals to the value, which is the data that we're going to be putting inside this our empty node. And the next is pointing to null because there is no node in the sequence, so this is just an empty node. That's why this next is pointing to null. So now this is out of the way. We're going to create our linked list, which will create various methods and compare them to array method in terms of time complexity. So to create our linked list, we have to call a class as well, which we call linked. And remember, guys, this stuff can change. It doesn't mean it's not compulsory. Your class name has to be linked. It can be any name you want it to be by choosing. So in our linked list, remember our linked list is a multiple nodes in a sequence, and where each node contains a head, a tail. So we're going to state that. So our head is going to be mapped to a node, which is the node we created before on node or null. So we have a tail because this is an empty node. So we are preparing our linked list for nodes for node. So another thing we're going to have in our linked list is our length, to know how many nodes are in our linked list. And we're going to map it to number. So we're going to call our constructor. So we're saying our head is equals to null and our tail is equals to null because our node is empty. We don't have a value inside our node yet. That's why we're saying our head is equals to null and our tail is equals to null. So our length is equals to 0 because presently there's no node in our head. So the first method we're going to be looking at today. So we're going to create a method which is going to add a node into our linked list from the back. And if you can remember in array method, in array has a method which does that, which is push method, which adds new elements to the back of the array. So we're going to create a method which mimics that method and test in terms of time complexity, which is faster and more preferable to use. So I'm going to call my method inside my linked class method because there's no much space, that's why I'm cleaning it. So I'm going to call this method push. You can choose to call your method whatever you want, but I still choose to call it push. And it's going to have a parameter which I'll call value. And I'll map the number. So inside our push method, we're going to create an instance of the node, the empty node we created before. So we're going to say let node be equals to new node. I'm going to pass our parameter value inside here. And we'll call in our if statement. And we'll say if exclamation mark this dot head, this should happen. What this condition is saying is if there is no head in our node, if our node is empty, then this should happen. So we should have this dot head equal to node, which is this node we created here, and this dot tail should be equals to head and this dot head. So we're going to call our else statement. Which will pass in our condition. So in our else statement, I'm going to say this dot tail exclamation mark dot next should be equals to node. So what this condition basically is saying is the tail, since we are making this method to add to the back of our linked list.